In this video, I'm going to talk about the sum and difference of cubes. So in the previous video we talked about the difference of squares, so this is going to be very similar to what we talked about before. We have a couple of formulas, just like we had with our difference of squares. We had one formula. So the sum of cubes is going to be a cubed plus b cubed, where a and b are the two terms that were cubed. So once we find that cubed root for those, we're going to say a plus b is the first quantity, times, I have the second quantity, a squared minus ab plus b squared. Where the difference of our cubes has the minus sign instead of a plus sign, so you'll notice the only differences in the formula are, instead of a plus b at the beginning, we'll have a minus b, and then instead of, in our second quantity, instead of the second term being minus, it'll be plus. So the formulas are pretty close to one another, but they are just formulas, so we're going to find our a value and a b value, and we're going to plug stuff in. Okay, so if this is our first example, x cubed plus 27, we are going to ask ourselves, well, what got cubed to give me x cubed? And what got cubed to give me 27? Because once I find that out, that'll be my a value, and that will be my b value. Well, the x is pretty easy, because what got cubed to give us x cubed? Well, just x. And what got cubed to give us 27? Well, 3, because 3 times 3 times 3 is going to be 27. So then, let's take a peek at this formula real quick. So we have sum of cubes tells us we're going to take a plus b. So a in this case is x, and b is 3. So I'm going to take x plus 3 as the first quantity. And then if I sneak back up here again, we have a squared minus ab plus b squared as the second quantity. So a squared is just going to be x squared. And then I have minus a times b. So I'm going to multiply them two together. So x times 3, but I'll put the coefficient first, so I'll just say 3x. And then plus b squared. So if the b is 3, b squared will be 9, just like that. So right here is actually the factored form of x cubed plus 27. Our second example is going to be 125y to the 6th minus 8. So when we look at these, we notice automatically we have two terms and they're being subtracted. So typically you're going to want to look for first is a difference of squares, maybe a difference of cubes. Well, 125 is not a perfect square and 8 is not a perfect square. And we can't factor anything out of here to make them perfect squares. So let's try cubes. Well, 125 is a perfect cube and 8 is a perfect cube. So I bet we're going to use difference of cubes, which we kind of saw last time when we looked at our formula. Difference of cubes is slightly different than sum of cubes. Okay, so let's figure out what it is that we're cubing here. So what was cubed in order to give us 125y to the 6th? And what was cubed in order to give us 8? Well, the cubed root of 125 is 5, and then y to the 6th. Well, remember, power of powers, it's what number times 3 made 6? So it looks like it's going to be 5y squared, because 2 times 3 makes this 6. And then what got cubed in order to give us 8 should be 2, because 2 times 2 times 2 makes that 8. So we're going to say the a value is 5y squared, and our b value is 2. So if we know those two pieces of information, we can use our handy-dandy formula, which says the difference of cubes is going to be the quantity a minus b, and then we have this second quantity. So let's kind of push that up for a second. So the first one was the a minus b, so I'm going to say 5y squared minus 2. Okay, so the second part of this is going to be a squared plus ab plus b squared. Well, whenever we take a squared and b squared, sometimes we can have a little trouble with that. So if our a was 5y squared, we need to square that in order to put that here as the first term. So 5 squared is 25, and y squared squared should be y to the 4th. And the second part of that is plus ab. So we're just going to multiply them together. So 5y squared times 2 should give us plus 10y squared. And then the last critter is going to be b squared, which is going to be 2 squared is going to be 4. So I'll say plus 4 right there. And this is going to be the factored form of 125y to the 6th minus 8. In our third and final example, I have m to the 6th minus 64. Okay, so again the question kind of asks us, is this difference of squares maybe, or difference of cubes? Well, it looks like we probably could use difference of squares on this, but let's use difference of cubes, just because that's the video we're talking about right now. So what was cubed in order to give us m to the 6th, and what was cubed in order to give us 64? Well, again, what times 3 makes 6, so it should be m squared, and then the cubed root of 64 should be 4. So we're going to say our a value is m squared, and our b value is 4. So, given our formula with the difference of cubes, let's look at that one more time. So a cubed minus b cubed, so is the difference here of a minus b, and then we have a squared plus ab plus b squared. So if we do a minus b at first, we'll have m squared minus 4. And then for our other one will be a squared, which is m squared squared, so m to the 4th. It'll be a plus sign right there, so times ab, so m squared times 4 makes 4m squared. And then b squared, so it'll be a plus 16 right there. Okay, well I notice something when I look at this. This m squared minus 4 happens to be a difference of squares. So if I were to bring that down here, m squared minus 4 should be m plus 2 and m minus 2. Okay, well this thing, I can't really factor that right now. It is factorable, but not by something very nice. So m to the 4th plus 4m squared plus 16. So here shall be our complete factoring of m to the 6th minus 64. We could also look at this another way. What if we had started by doing difference of squares, like I mentioned before? Because m to the 6th minus 64 could be difference of squares. We could ask ourselves, what got squared to give us m to the 6th, and what got squared to give us 64? Well, m cubed got squared, and then it looks like squared makes 8. So if we have this, we're going to have the difference of squares, so it'll be m cubed plus 8 and m cubed minus 8. Well, hey, that looks crazy, because here's sum of cubes and difference of cubes. So if we happen to go ahead and finish this, let's go ahead and do it. So it'll be m plus 2 times the quantity m squared minus 2m plus 4. And then for the difference of cubes will be m minus 2, and then m squared plus 2m plus 4. So actually we have all this stuff that gets multiplied to give us this difference of squares, which really just came from m to the 6th minus 64. So you could always reorder that if you wanted to, but that's what that looks like completely factored.